Quan from China Alibaba Cloud. My topic is the perfect solution for lab migration with pass-through device. Welcome to my topic. At first, let me introduce the background of this topic. Some of the devices are passed through to VM and then benefit our customer directly, such as GPU device. But in my topic, the pass-through device is the virtio hardware device. Virtio hardware device was introduced in last QEMU open forum. Open forum. You may find some strange points as the QEMU virtio device is always QEMU emulated device, and VM front-end Java can communicate with the backend PV backend directly. No need to use VFIO. Like other device, pass-through device, we leverage VFIO to pass through the virtio device to VM, and the front-end Java is working as usual. No need to patch them. It supports VM, Linux, VM and Windows, Linux and Windows virtual machine, and the front end. Sorry. As some other pass-through device. Useful for load balance and software maintenance, where lab migration is a must-have in public cloud data centers. But so far, upstream doesn't support lab migration with pass-through device. And also, there's some POC to enable pass-through device with lab migration with pass-through device. I will also talk about them in coming page. Before to dive into the lab migration with pass-through device, let me introduce the general lab migration flow. Lab migration is the interesting ongoing topic. At migration start, we should start log dirties and mark all the page dirties. And during iterate copies, we should keep sending dirty page to destination. And stop device, stop and copy stage. Stop the device if condition reached. And sending the remaining dirty page to destinations and resume the VM on destination. Also, we should save virtual device, save virtual device, and restore virtual device status on destination. On general lab migration flows, VM is not involved. From VM views, vCPU, memories, or device state are the same from host A to host B between the stop and copy and resume stage. For vCPU and virtual device, it's easy to save and restore, but the memory looks complex because not only vCPUs but all the virtual device to write the VM memories. PML can help us to check the dirty page from vCPU writes. And when virtual device writes the VM memories, should update the dirty bitmap. And then QEMU synchronize the QEMU dirty bitmap and transfer the corresponding page to destination. Okay. What's the problem to enable LAM migration with pass-through device, and what's the difference between general LAM migration and LAM migration with pass-through device? First, we should change as general LAM migration flows. We should save the vCPU state and the virtual device state from source host to destination. And but not only but the memories looks much a big challenge, because not only vCPU virtual device writes VM memories, but also the device DMA will write the VM memories. And so far, IOMMU is don't support to check the dirty page, and the spec is published, but the hardware is on the roadmap, but not ready. Also, we should save the hardware device state to from source to destination. But the device is not designed for LAM migrations, such as Intel NIC. A lot of registers are read-only, and it's not easy to save them and restore on runtime. Let me introduce this POC in detail. First is from Intel. Intel introduced a self-emulation layer for Intel NIC. It's based on VM device driver. They save and restore read-write register. Read-only registers are stateless. Maybe they leave them inconsistent with device data and VM driver. Also, they introduce a self-emulate device DMA page. Make a per page dummy write in interrupt handler. Dummy write is read a byte and write a byte. Then when PML is enabled, can help us to check the device DMA page. Also, the second is redesigned hardware and VM drivers, such as some smart NIC. Because this is designed for LAM migrations, so it should be aware of LAM migration. When LAM migration starts, it should start to log the dirty page, and start log dirty page. Also, the drivers support self-emulate device DMA page as the first one, and all registers are read-write. We can save and restore them on runtime. And the third is IOMMU setD field in page start entries. Yes, the VDD spec is published, but VDD hardware is on roadmap, but not ready. I think this is the best solution to check the DMA page, but I don't know when it's ready. I'll introduce my solutions. Our solution is based on Intel virtio hardware device, or extend the capabilities of device, and extend the migration code and the VFIO framework to leverage these new capabilities. Details in coming page. First, the new capability of device. It should be aware of LAM migrations. Yes, at start of LAM migration, they should start to log and allocate the device dirty bitmap. Also, I will introduce the device dirty bitmap on coming page, and also we save restore device state on runtime. On all the registers are read-write. We can save them and restore them as the emulate device. Also, we can extend the migration callback. be aware of line migration. First, we should allocate at the start of line migrations. We should start log dirty, log the device dirty page as start line migration, and allocate device dirty bitmap based on VM size, 1 page per bit, and stop the log the device DMA page after stop and copy. Let me introduce the device dirty bitmap in details. First, it's based on VM memory size, and the DMA and sets correspond. The device should have capability to DMA and set the corresponding bit in device bitmap. Also, QEMU can synchronize and clear the corresponding bit in device dirty bitmap, and all the actions should be atomic, both software and hardware. During the line migrations, the device states include QEMU PCIe configurations, MSI X table, and what are device common states, and what are specific states. And for detailed, you can refer to QEMU emulated code. It's quite similar as the hardware one. Then I will introduce the QEMU migration thread. At the start of line migration, the migration start should notify the device to start log device DMA page. And after line migration, it should notify device to stop log device DMA page. And QEMU synchronize the device bitmap. Also, during the line migrations, the QEMU will synchronize the KVM dirty bitmap. You'd better extend the VFIO hook on coming page in detail, which save the device state and restore device state. Quite like we can extend the VM handler to do this. Also, patch VFIO. This is a key module to enable line migration with pass-through device. First, as mentioned, current upstream code doesn't support line migration with pass-through device. In VFI modules introduced unmigrable parameters. They always set, but to enable the line migration with pass-through device, we should clear the VFI unmigrable parameters for given device ID and vendor ID. In my topics, it's the specific virtio hardware device ID and vendor ID. Also, we extend VFL memory listeners. In log start, quite like the KVM does, we sync the device dirty bitmap, and in log global start hook, we start to log device DMA page for every device, and log global stop can stop the log dirty for every device. I think it's benefit to extend the VFIO memory listeners. We can no care about the QEMU spin log, and you know there are a lot of spin logs in QEMU. Also, we can save and restore device state. We can introduce a VFIO VM handler to save and restore device state. Also, before to start MSIX, before to start device, we should enable MSIX interrupt. There's two chances to enable MSIX. One is the device driver initialization, and the other is resuming device state. I think there will be some different hardware behaviors. In initialization, device driver initialization, we set the enabling bit and the master of the device, but per vectors it's unmasked. But during the RAM migration, we're resuming the device, resuming the MSIX. We're also enabling the device capability bit, but the master of all device is not unmasked. But per vectors may be masked. So we better introduce a new function to enable the MSIX from the RAM migration. In constructible general RAM migration, the above is general RAM migrations. New action required. As migration starts, we should start to log device DMA page and sync. During the iterate copies, we should sync device dirty bitmap, and also we should at stop and copy stage, we should QEMU should also sync device dirty bitmap and stop log device DMA page and save the device states. On destination host, we should restore device state and resume the device and resume the virtual machine. And some tips. First, we should enable MSIX after vCPU post-initialization because compatible with the VTD post-interrupt. Because when we enable the vector of the MSIX, we should set the vCPU affinities. Otherwise, some Windows RAM migration for some Windows will make the host crash. Also, we should build IOMMU page mapping before to start device. Yes, just a tip. No need to patch. The current code is working. So, and also we're not compatible with post copy RAM migration because the device can DMA the page and the vCPU couldn't check and mark it dirty. Some future work. In this topic, I just show examples for how to enable the RAM migration with pass-through device. I hope more SR device can support RAM migrations. Also, we can leverage our MMU to check dirty device DMA page if hardware is ready. Also, we should reduce the downtime of RAM migrations because we need to sync the device dirty bitmap. It's extra actions to general RAM migration flows. Also, it should be compatible with QEMU emulate device without device. Yes, it's interesting, but I hope I can discuss this in next year if the QEMU Open Forum accept my topic. Because so far the RAM migration is always based on between the same device, same virtual device. For example, if we RAM migration with hardware virtual device and QEMU emulator virtual device, the I/O path or the I/O path and the I/O device are not the same, but that's working. I will show it in next year. And upstream, I hope I can upstream the framework to upstream code. That's all. Thank you. Any question? Okay. Also, we can discuss offline.
So the dirty bitmap is maintained by device itself?
No. The dirty device bitmap is maintained by VFIOs. It's a host memories, but device just know where the device bitmap is and set a corresponding bit. At the start of line migrations, we can allocate the memories for device dirty bitmap, and after line migration, we should free the device dirty bitmap. It's also on VM size. It's not in device. It's in host, but device know where it is. Okay.
So, do you have a host driver for the work?
No host driver, because we pass through the device into virtual machine, and the virtual machine front end driver is working as usual, so there's no host driver.
Okay, so the bitmap job is work just in the VFIO driver, right?
Yes, it supports Windows, Linux, and the current upstream code is working. No
Okay.
need to patch the front end driver.
Okay, thank you.
Yeah, so I have two questions. So the first one is that you mentioned that you don't have a host driver, right? But you introduce new API like save and restore device states. So who provide that implementation on the host side? So this is the first question. Second one is
sorry, let me answer your first question. First, in these pictures, I have introduced the actually the QEMU thread extend a hook, VM handlers.
Okay, so you're saying so in QEMU, so for the VFIO, you extended the hook. So it will, so the states.
Sorry, my mistake. Is VFIO extend a hook, a log sync to.
It's like
sync.
a quark. It's like a quark.
Sorry.
So the hook is like a quark. So like that, you are right now provide a volatile device. So like you in the QEMU, you add a hook to say, add a quark in QEMU to say, so I can save and restore volatile device. But your driver, you don't have a driver, right?
Yes.
So do you need to read the states from the device?
Read the state device.
The real hardware device.
Device.
The states.
Sorry, maybe that's a detail of hardware. We can discuss.
Okay.
Offline.
This is the first question. So the second question is that I'm trying to understand the pass-through way. How's the way you are going to support like 0.95? So volatile 0.95 is the most widely used one. So do you support that in the pass-through way?
Sorry.
So I mean in the volatile, so 0.95, that version, so a modified 0.95 driver in the gas. So the pass-through way is just work or have some, you introduce some extra effort on that?
For this question,
okay, maybe we can discuss offline. And I will mention another thing is we are working on the similar things. We introduced actually VDPA, so probably we can talk offline. So I think in your future plan, you are going to support a compatible emulated volatile device. So probably we can engage on that topic.
That's for the next year.
Next year.
Okay, thank you.
I have a question that, so your virtual hardware is implemented by FPGA or ASIC?
Made by FPGA.
Okay, so what kind of real device like NIC or block are you working on? I mean, what I/O hardware should be only an abstract layer, you know? I'm not sure what kind of is it NIC or something else.
Sorry, maybe I couldn't share the hardware in detail.
Okay.
Hi. When you're doing pre-copy migration like that, QEMU may need to throttle the vCPUs for the migration to converge. In this model, where you have the device directly doing the MA, do you envision anything in your API to actually tell the device to throttle how much memory it is dirtying during the migration, and how it would look like?
During pre-memory copies, I think the QEMU should tell the device or the VM memory size as a migration start. Is that the answer to your question?
Does it need throttling, slowing down?
Slowing down. Let me think twice and talk to you.
So,
Next year. That's just the POCs. We just try to implement our idea.
So I have a question. So you said you basically provide a hook into the VFIO, right? Right here.
Oh, okay.
Yeah, so you basically provide a hook into the VFIO. I assume, and it also said that you don't have a driver on the host, right? So that means your dirty page information is basically a superset of your actually working set, right? So the dirty page you reported by this API is actually a superset of what actually gets dirtied by the device. And since you actually I assume it's an FPGA device, you already know you own the driver actually from the guest, right? Do you actually compare how big is the superset versus the actually active working set?
In these scenarios, maybe in our designs, maybe there will be not a device hardware drivers, but to get access the device in specific way to get the device bitmap.
Let me make an example. Right? For
Maybe
example,
your question is quite detailed about the hardwares. Maybe I couldn't.
Let me make an example, right? So let's, for example, say the superset is probably 10 gigabyte, right? You basically, from your VFIO hook, you see the data. Actually, the memory actually gets pinned by the device as 10 gigabyte, right?
Yes.
But actually, the only active working set only is a few megabyte. Is that possible? Do you actually have that data? Because from the interface I see, you can only know the superset of the data. Now the active working, the dirty set.
Dirty.
Yeah, whatever is actually mapped into device, that's what you call dirty page, but that is actually not the dirty page.
Frankly, maybe I couldn't follow your questions.
Oh yeah, we can talk offline.
We can discuss offline. Sorry.
Hey, thank you. Can I ask a question before the next one? Okay, I'm sorry. Here. Thank you very much for this topic. So I have a question. Is about you mentioned that you are using kind of FPGA, right?
Yeah.
So is it possible to share some kind of performance data to us, like what about the performance, about the software without the performance data?
So I didn't have the data.
Okay, thank you very much.
Thank you.
Yeah, I have another question. So the life, regarding the time it takes to migrate, the fact that you need to take the dirty pages from the hardware device, does that make the live migration longer, or is it the same amount of time? Do you have any details on that?
I think it will be longer than general live migration flows, because you should deal with the device dirty bitmap. You should sync the device dirty map and get much more the device DMA page. So I think it will be much longer.
Okay.
Also, in our topic is to reduce the downtime, also the total time. That's all.
Thank you.
Thank you.